Hello everyone, welcome to week 7 of NPTEL Analog Communication Problem Solving Sessions conducted by Swastik Chakraborty, a research scholar from IIT Kharagpur. So with that we will start with the week 7 problem solving session. In week 7 we will be dealing with probability theory. So please do watch the lectures concerning probability theory in the analog communication NPTEL course, and then please follow this problem solving session or you might feel a gap. So with that being said, we will start with the problem solving session. And the thing is, I will be solving 10 problems, I will first read out the questions, then I will give the answers. And the thing is, you should follow along. You should try the questions on your own first by pausing the video, and then you should start seeing the answers. This is for your own practice. I hope you enjoy this problem solving session. With that, give me 2 minutes to set up everything, and then we will be starting right ahead. Okay, so week 7. Yes, so we will download this PDF. And downloading. Let's open it. So here we go. So this is, I'm sorry, this is assignment 6, not 7. There seems to be some mistake here. Okay, the heading is wrong. It's fine. So it's assignment 7. So for assignment 7, we will start with the first problem. The first problem states that x and y are correlated random variables. Then E, that is expectation of x given y, is not equal to the expectation of x. Is it true or is it false? So please focus on question number 1. The expectation of x given y is not equal to the expectation of x, where x and y are correlated random variables. Is it true or is it false? So, in probability theory, the opposite of correlated random variables is independent random variables. So, if a random variable is not correlated, they are independent. So, random variables not correlated is identical to random variables not independent. So they are, in the term of probability theory, they are the same thing. So not correlated means not independent. If x and y are independent, then what is the definition of independence? That the occurrence of one of the random variables do not depend on the occurrence of the other. So the occurrence of x should not depend on the occurrence of y. So the occurrence of x given y, the expectation of x given y should be equal to the expectation of x. This is independence. Independence means that x given y and x have the same expectation, that is the same probability of occurring. So that means the expectation of x does not depend on y. So if x and y are correlated, that means they are not independent. Sorry, random variables correlated means they are not independent. Random variables correlated means they are not independent. So x and y are correlated means they are not independent. Then clearly Ex, if X and Y are correlated, then Ex given Y should be not equals Ex. From this we come to the conclusion that the answer that the statement given here is true. If X and Y are correlated, Ex over Y will not be equal to E of X. Now, X and Y in the second question are uncorrelated, are these. Then they must be independent. In the previous example, I have said that the correlation and independence are similar things. But that was actually a bit wrong. For the case of the question 1, it's true. But correlation and independence have a degree of difference between them. So here rather than solving the question, I will directly go to the answer because there is nothing to solve. This is a concept, not a problem. So X and Y are uncorrelated, then they must be independent. If X and Y are independent random variables, then they must be uncorrelated. So this one is true. If X and Y are independent, then they are uncorrelated. We have seen that here. So if they are not independent, they are correlated, which means if they are independent, they are uncorrelated. But the converse is not necessarily true. So if two X and Y are correlated, so if X and Y are uncorrelated, they may still be dependent. So this is like a statement where in one direction it's true and in one direction it may be true, but not necessarily. So here we see that we will illustrate this with an example. Example of a correlated but dependent random variables. So we need correlated but dependent random variables. Sorry, uncorrelated but dependent, independent. So they must be, if X and Y are independent, they must be uncorrelated. But if X and Y are uncorrelated, they may still be dependent. So we need an example of an uncorrelated but dependent. Okay. Okay. Now let's go proceed to the example. The example that I will provide to illustrate this statement is, I'm sorry. See, this is, let X be standard normal. So X is a standard normal distribution and Y is equal to X square. So I will prove they are uncorrelated but not independent. Uncorrelated but not independent. This is what we have to prove. To prove now E of X is 0. Also, because it's standard normal, so the mean is 0. Also, E of x cube is 0. All the central raw moments of a standard normal distribution are 0. So, all the odd raw moments, I mean to say, are 0. Now, let's take EXY. We know this. We know. So, these all the odd raw moments are 0. We know this. This is given. So, what is E of xy? E of xy is nothing but E of x into x square. So, it's E of x cube, which is 0. So, x and y are uncorrelated because EXY equal to 0. We have completed first part, that it is uncorrelated. But now we have to show it's not independent, that is, it is dependent. So, we take this example. P 0 less than x less than 1 and y greater than 1. So, what is the probability that x is between 0 and 1 and y is greater than 1? What will be the probability? See, x is a number between 0 to 1. X is a number between 0 to 1 and y should be greater than 1. But y equal to x square. If x is less than 1, y equal to x square is never greater than 1. So the occurrence of this, the chance of occurrence of this is 0 because y is x square. So if x is less than 1, x square cannot be greater than 1. So this is 0. Now let's break it down. P 0 to x to 0 to 1. What is this? This is nothing but a number. The integration of Gaussian between 0 and 1. So this is 0 and 1, 1 by root 2 pi sigma square e to the power minus x square. Oh, there is no sigma square, sorry. It is a e to the power minus x square by 2 dx. So this is the answer. So this is some number, let's say k. And what is, we are not evaluating the integration, we are keeping it as it is because the numerical value is immaterial for us. And what is Py greater than 1? Is equal to Px square greater than 1, which means Px less than minus 1 or Px greater than minus 1, greater than 1. So this means 1 minus Px between minus 1 to 1. That is, if x square is greater than 1, so x can be less than minus 1 or x can be greater than 1. But this means that x can be less than minus 1 or greater than 1. So it cannot lie between minus 1 and 1. So it is the complement of the event that x will lie between minus 1 and 1. Thus, this will be 1 minus minus 1 to 1, 1 by root 2 pi e to the power minus x square by 2. So dx, since it is symmetric, since Gaussian is symmetric, this will be basically 1 minus 2 into 1 to 0, 1 by root 2 pi e to the power minus x square dx. Done. So this is 1 minus 2 into some k, 1 minus 2k. Therefore, P0 is k into 1 minus 2k, which is, so the thing is, sorry, the product of these two is equal to k into 1 minus 2k, which means it is not equal to 0. Therefore, P, the probability of occurrence of 0x1 y greater than 1 is not equal to hello and welcome to the live session class. Please follow along. So P P was 0 to 1 and y greater than 1. Clearly this was 0, and the product, this is the intersection of the two events, and the product of the probability of the two events will be 0 to x less than 1 into P y greater than 1. So this is k into 1 minus 2k as we have seen, and k into 1 minus 2k is not equal to 0. Therefore these two are not equal. Thus, therefore x and y are not independent. So we have shown the existence of a random variable, which is a pair of random variables rather, which are uncorrelated, as we have seen by showing that expectation of xy is equal to 0. So they are uncorrelated, but we have taken a particular segment and shown that they are not independent, they are dependent. So we can say that in question number 2, if x and y are uncorrelated, they must be independent, is a false statement. There are pairs of random variables who are uncorrelated, but they can be independent. This question PDF and the video of this recording lecture will be uploaded to the appropriate place in NPTEL website for you to later follow along. And now in the next question, question number 3, fx equal to lambda e to the power minus lambda x, where x is in the entire range of real number, is a valid PDF. So what is this distribution? This distribution is basically the exponential distribution. So fx equal to lambda e to the power minus lambda x, and then they are saying that the range of the x is minus infinity to infinity. Now this is a valid PDF. They are stating, is it true or is it false? So what is the first property of a PDF? That it should integrate within its domain, it should integrate to 1. So the integration of a probability density function over its entire domain is equal to 1. That is, the sum of all probabilities possible should equal 1. Thus the PDF that is given here should integrate to 1, or else this is not a valid PDF. So we have to see whether the integration exists in the range of minus infinity to infinity, and whether it, even if it exists, whether it adds up to 1 or not. So first it should exist, and second it should add up to 1. So minus infinity to infinity fx dx, this thing should equal 1 for fx to be a valid PDF. So let's see, minus infinity to infinity lambda e to the power minus lambda x dx. Now this lambda is a scalar, so we can take it out, of course. So lambda infinity to minus infinity e to the power minus lambda x dx. Now we integrate it. The integration of e to the power minus lambda x is lambda e to the power minus lambda x by minus of lambda. So the lambda and the lambda cancel, and here it's infinity and minus infinity. But see, when you put infinity, it is e to the power minus infinity in the limit by minus 1 here. So minus 1, and when you put negative infinity is e to the power infinity. So this goes to infinity. So finally the limit tends to infinity. Therefore integration of lambda e to the power minus lambda x over the entire real number range does not exist. DNE. Therefore fx is equal to lambda e to the power minus lambda x is not a valid PDF is not a valid PDF over minus infinity to x infinity. But you can try it out yourself at home. If the range was given as 0 to infinity rather than minus infinity to infinity, the same exponential distribution would have been a valid PDF. The same lambda e to the power minus lambda x would have been a valid PDF if the range was infinity to 0 rather than infinity to minus infinity. So that is a lesson that the PDF's existence also depends on the domain, not just on the function. Now for the fourth question, fx, that is the PDF of the random variable capital X, is given as e to the power 3x by 4. So where x exists between 0 to b, and when x is outside 0 to b, the value is 0. So what is, for the function to be a valid probability density, the constant value should be. That is the question. So again, same question basically, valid PDF. So the integration fx should be 1. Question 4. For fx to be valid PDF, it should integrate to 1. Now, what is the range and what is the PDF? Let's see. The range is 0 to b and the PDF is e to the power 3x by 4. So the range is 0 to b and the PDF is e to the power 3x by 4 dx. So this should equate to 1. Does it? Let's check out. So e to the power 3x by 3 into 4, because e to the power ax is e to the power ax integration is e to the power ax by a, and we limit it between 0 and b. So it's e to the power 3b minus e to the power 0, which is 1, by 12. Now what should this equal to? This should equal to a big 1, because it should be a valid PDF. For valid PDF. Now, so e to the power 3b minus 1 is 12. Therefore, e to the power 3b minus 1 is 12, implies e to the power 3b is 13. So if we take a ln, it is 3b equal to ln 13. So b is 1/3 of ln 13. That is the final answer, 1/3 of ln 13. No need to evaluate it to decimals because the answer is in ln format. So what is the answer? The answer is none of the above. Option D, because ln 2, ln 16 and 1/4 ln 12, none of them match. So it is 1/3 ln 13. See, I am not wrong. So this is 1/3 ln 13. Okay. Now let's go to question number 5. Okay. Question number 5 says the three statistically independent random variables x1, x2 and x3 have mean or expected values. x1 bar equal to 3, x2 bar equal to 6 and x3 bar equal to -2. The mean value of g x1, x2, x3 is minus 3x1 minus 3x1, x2 minus 3x1, x3 plus 4x2, x3. So the mean value of the three random variables together is this. That is the expectation of x1 intersection x2 intersection x3. Now, for question 5, the mean of x1, x2, x3. Let's see the problem again. Not this one. Let's close it. Not this one too. Let's close it. Yeah. So x1, x2 and x3 have a combined mean So the intersection mean x1, x2, x3 is the mean value of g x1, x2, x3. Sorry, it should be written like not like this, but rather as g x1, x2, x3. It's a matter of representation, and this will be equal to expectation of that big expression. So what is the big expression? That big expression is negative 3x1, x2, negative 3x1, x3 plus 4x2, x3. Negative 3x1, x3, negative 3x2, x3 and plus 4x2, x3. Sorry, this will be x1, 4x2, x3. So using the linearity property of expectation, expectation is a linear operator. So we can just write like this. Now, expectation operator is a very nice operator. It also distributes over products. So this will be now let's substitute the value. Let's remember it. X1 is 3, 6 and minus 2. Okay. So let's see it again. I forgot. 3, 6 and minus 2. Let's go ahead and put them. 3, 6 and minus 2. So this will be 3, this will be minus 2 plus 3, 6 minus 2. So this will be 6 and 3 and this will be 6 and minus 2. So negative, negative, positive, 3, 3, 6, 6 2s are 12. 18, 18, 3, 54. Minus 24, 48. So 6 plus 12, this is 18. So the required value is 18. Let's see. Did I put the correctly? Okay, negative 336. Okay, I beg your pardon. It's negative 336. I put the values incorrectly. This will be negative 336. And this will be negative 33, negative 2. Negative 33, negative 2. Negative 3, 3. Negative 3. So all are negative. So this will be a rather large negative number. So 18 this is 12 and this will be 48. Again some problem is there. 58, 66, 68, 3 minus 2, 24, 48. Right, this is not 18, this is 54. So 54 plus 48 minus 12. Okay, you please check the calculations. I am getting lost in the calculations, but the answer is supposed to come negative 84, but I am getting negative 90. So please check whether this is negative 84 or negative 90. I am getting negative 90, but the answer key is providing negative 84. So this is a disputed one. So this one is saying negative 84, but I am getting negative 90. So please re-evaluate this one and see how much you are getting. If you have any discrepancy, please feel free to write in the NPTEL forum. If you have any discrepancy, you find any question to be wrong, please write in the NPTEL forum and it will be addressed by me and my teammates accordingly. Okay? So you can raise a dispute on this question. First solve it in your homes and then raise a dispute on this question if the answer still doesn't match. Okay, now let's go to question 6. Random variables x and y have joint density fxy is equal to 1 by 12 e to the power minus x by 4 minus y by 3 ux uy. So this one is a bit complicated. So there is a joint density of exponentials and ux and uy are step functions, which means this density function will only be non-zero when x is greater than 0 and y is greater than 0. I will be taking a 5 minutes break. Please try to solve this question, and when you are done, please fast forward 5 minutes. So the time on this local computer clock is 7:30. Please fast forward to 7:35 in this local computer clock and you will get your class resumed because I'm taking a 5 minutes break. Thank you. I'm sorry for the additional delay on my side. So okay, let's start with the random variables which have a joint density of 1 by 12 e to the power minus x by 4 into e to the power minus y by 3, and it is between 0 to infinity only for both variables. So what's the joint density? The joint density is e to the power 1 by 12 of e to the power minus x by 4 minus y by 3, and x and y are both positive. That's it. So x and y are both positive. That is signified by ux and yx. So what is the probability of x being a positive real number and y being less than minus 1? So the answer should be very easy to get. The answer is a big fat 0. Why? Because y can never be greater than less than 0. If y is less than 0, then this whole ux and uy you see, uy equal to 0 हो जाएगा. So this whole fxy x comma y will become 0. So your whole probability density will become 0. So here instead of x greater than 0, y greater than 0, let's write like how they have written ux, uy. Ux equal to 1 if x equal to x greater than 0, 0 else. Similarly, uy equal to 1 y greater than 0, 0 else. Now, p x is 0 to infinity. So x occupies the whole range and y less than minus 2. Here 1 by 12 integration 0 to infinity, integration minus infinity to minus 2, 1 by 12 e to the power minus y x by 4 y by 3. Ux is 0, ux is 1 because x is positive, whereas uy is 0. So u 0 to infinity is 0 and u minus 2 to minus infinity is 1, 0. Sorry, this is 1. So this is whole thing is 0. Done. So this whole thing is 0. So question 6 answer is option D, none of these, as it will be 0. Now a random variable is uniformly distributed on the interval minus 5 to 15. Another random variable y equal to e to the power minus x by 5 is found. The value of expectation of y is. Okay, a random variable x is uniformly distributed on the interval minus 5 to 15. Another random variable y equal to e to the power minus x by 5. So the expectation of e to the power minus x by 5. Let's do it. in 2 minutes. First you try for 2 minutes. Okay. A random variable x is uniformly distributed on the interval -5 to 15. Another random variable y equal to -6 to the power -6.5. Let's proceed. Expectation of y is expectation of e to the power -6/5. That's it. Now we do the expectation operation. E to the power -x/5 fx dx, and you do it within x is within -5 to 15, so you do it within -5 to 15. And what is the PDF given? The PDF is given as uniform distribution. So 1 minute, yes, fx is, so x is distributed as uniform between -5 to 15. So fx is equal to 1 by 15 minus -5 between -5 to 15, 0 else. So 1 by 20 when x is between -5 and 15, and 0 else. So this will be just my 1 by 20 e to the power -x/5 dx. So 1 by 20 e to the power -x/5 by -1 by 5 e to the power ax by a between 15 and -5. That's it. So this 1 by 5 will go up. So this will become -5 by 20 e to the power -15 minus e to the power 5. 15 by 5, sorry, e to the power -15 by 5 minus e to the power -5 by 5. So let's zoom out a bit, and this will become -1 by 4 e to the power -3 minus e to the power 1. So 1 by 4 e minus e to the power -3. And if you calculate it, let's open the calculator. So exponential, right? No, not this one. Where is exponential? Sorry. So what is the expression? The expression is e minus e to the power -3. E minus e to the power okay, I'm not that comfortable in Microsoft calculator. Let me use the Google one. Okay, a minus a to the power, so this one, and this will get divided by 4. So your answer is 0.667. Your answer is 0.667. So answer is, let me write it properly. Answer is 0.667. That is the answer. So 0.667. Let's see whether we are correct or not. So option B, 0.667. And actually you can solve it without even solving the question, because expectation of y is not very likely to be these values. It is likely to be with less than 1, because this is e to the power minus something. So this is less than 1. Okay. Anyways, let's not go there. So we have solved it. Okay. The CDF of two random variables x and y are given by, so pi by 2 plus arc10 x by 2 into pi by 2 plus arc10 y by 3. Okay, for this to be a valid CDF, the value of A should be. So this is not a PDF. Now we come to the topic of CDFs. So to be valid PDF, so we are moving to question number 8 now. Okay. So we are moving to question number 8, where fxy equal to a by 2 pi by 2 plus tan inverse x by 2. Okay, for anything to be a valid PDF, it should sum to 1, right? So for valid PDF, it should integrate or sum to 1. In case of continuous, it should integrate to 1. One minute, please. হ্যালো, কেন কি হয়েছে বলো? আচ্ছা, হুম, হুম। তুমি এক কাজ করো, তুমি এই টেস্ট গুলো করেছো না, তুমি হসপিটালে একটা ফোন করো, করে বলো আমি এই টেস্ট গুলো রেজাল্ট পাচ্ছি আর খুব এমনি শরীরও খুব খারাপ দেখাচ্ছে, তাহলে কি আমি হসপিটালে নিয়ে যাবো, সেইটা জিজ্ঞেস করো। করে ওরা যদি বলে হ্যাঁ তাহলে তুমি চলে যাও, আর না হলেও চলে যাও। এটা বলবে যে আমার অবস্থা খুব খারাপ লাগছিল আর চাহনিও মানে শরীরও খুব খারাপ লাগছিল, তো তার জন্য আমার মনে হচ্ছে হয়তো তাহলে কি আমি ভর্তি করিয়ে দেবো এখন। ফোন করে একবার জিজ্ঞেস করে নাও, 2 মিনিট 1 মিনিটের কথা। বলবে তাহলে তাহলে বলবে তাহলে আমার এরকম হয়েছে, তাহলে আমি নিয়ে আসছি, ব্যাস এরকম বলো। দিদির কি এখন মানে এখন কিরকম আছে, কি স্টেবল আছে না খুব বাজে অবস্থা আছে? না নিয়ে যাও, নিয়ে যাও, নিয়ে যাও, নিয়ে যাও। কিছু না হলে দুদিনে তো, কিছু না হলে দুদিনে বেরিয়ে যাবে। ঘরে বসে বসে টেস্ট করাতে থাকলে তো এমনিই টাকা যেতে থাকবে। তার থেকে এবারে নিয়ে যাও, কিছু না হলে দুদিনে আবার চলে আসবে, লাস্ট বার যেমন হয়েছিল। মুখ করে একটু শুনতে হবে, একটু শুনতে হবে, সরকারি জায়গায় কাজ করতে গেলে শুনতে হয়, আমাদেরও শুনতে হয়। আমি এত পড়াশোনা করেছি তারপরেও আমার সরকারি জায়গায় মুখ শুনতে হয়। সরকারি জায়গা মানেই মুখ শুনতে হবে, তো কিছু করার নেই। মুখ না শুনতে হলে তাহলে জমি জায়গা বেচে প্রাইভেটে চিকিৎসা করাতে হবে, দুটোই অপশন আছে, আর কোনো অপশন নেই। এখন যদি তোমার শরীর, হ্যাঁ শরীর খারাপ লাগে, মুখ করুক না করুক চিকিৎসা তো করে দিচ্ছে, ভর্তি করিয়ে দাও। আচ্ছা আমি না এখন একটু ব্যস্ত আছি, একটু পরে কল করি নাকি, আমি ক্লাস থামিয়ে কল করেছি। হ্যাঁ 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 হুম হুম। Hello. So sorry for the disruption. Yes, for a valid PDF. Okay, now I have to plug my charger. Okay. So for a valid PDF, if this is what is true. Now what is fx? Fx is the CDF that is starting from negative infinity. It will go till x, fx dx. Let's keep not give it x to avoid confusion. Fz dz. Okay. So now minus infinity to infinity fx dx should be 1. That is non-negotiable. So what should we put here in place of x to satisfy the same condition? For valid CDF fx, for valid CDF fx, f infinity rather, should be equal to 1. Why? Because f infinity is, what is f infinity? F infinity is minus infinity to infinity fz dz. So what is the value of this? This should be, for a valid probability distribution, this should be 1. So f infinity equal to 1. So this integration small fx dx equal to 1 gets transformed to, is equivalent to capital F infinity equal to 1. So in this joint CDF, we just have to put infinity and we have to see whether it's 1 or not. That's it. So let's put 1 here. What is fxy? Fxy is a by 2 times pi by 2 plus arc tan x by 2 pi by 2 plus arc tan x by 2. Tab x arc tan x by 2. Arc tan means tan inverse. It's the same thing. Arc tan and tan inverse mean the same thing. And pi by 2 plus arc tan y by 3 into pi by 2 plus arc tan y by 3. Now, this is for f infinity comma infinity. So both variables should go to infinity. At that point, the CDF should be 1. So a by 2, pi by 2 plus arc tan infinity, arc tan infinity. And here also it's pi by 2 plus arc tan infinity. Is equal to a by 2 into pi by 2 plus pi by 2 into pi by 2 plus pi by 2. So a pi into pi square by 2 is equal to 1, implies a equal to 2 over pi square. That is the answer. 2 over pi square. So option number B, 2 over pi square. The envelope of the output signal of a radar system that is receiving only noise is a random voltage whose PDF is given as this x e to the power minus xs square by 2. Okay. The envelope of the output signal is given like this. The system gets a false target detection if x exceeds a threshold level of V volts. To make the probability of false detection 0.0001, then V greater than. Okay. So, if x is greater than V, okay, first let's write down the probability density. The probability density is Fx equal to x e to the power minus x square by 2. Now, let's go ahead and say that if x is greater than V, if exceeds the threshold level of V volts, then we get a false detection. So Px greater than V should be equal to 0.0001. That is the problem statement. P by the problem, Px greater than V should be equal to 0.0001, implies V to infinity x e to the power minus x square by 2 dx should be 10 to the power minus 4, implies, now we have to do an integration of x e to the power minus x square by 2. So we just put x square as some variable p, implies 2x dx equal to dp, implies x dx is equal to half dp. Therefore, this integration becomes, now the limits also change. v becomes, of course, v square, and this becomes, remains infinity, and this becomes e to the power minus p by 2, and x dx becomes half dp. So this will be equal to 10 to the power minus 4. So we are solving for v here. Implies so this will become e to the power minus p by 2 by minus half into half. So half of will cancel between v square and infinity, becomes 10 to the power minus 4. Implies e to the power minus infinity is 0, so it will be basically e to the power minus v square by 2. So take ln on both sides, ln minus v square by 2 is equal to ln 10 to the power minus 4. So v square equal to minus 4 will come on the multiplier, so it will become 8 ln 10. So v becomes root under 8 ln 10. Now let's specify it according to the options given, because clearly our root 8 ln 10 is not given, but don't worry. 8 can be written as 4 into 2, so v is 2 into ln 10 to the power 4, that is root 2 into ln 10,000. So the option answer will be root 2 ln 1000 or option 10,000, option D. A joint sample space for two random variables x and y has 4 elements: 1, 1, 2, 2, 3, 3, 4, 4. Probabilities of these elements are 0.1, 0.35, 0.05 and 0.5. The probability of the event x less than 2 and y less than equal to 6. So this is a simple counting problem. So x less than 2 means x can be only 1. X can be 1, 2, 3, 4, but here x less than 2, so x can only be 1. And y is less than equal to 6, so y can be 1, 2, 3, 4. So here technically the sample space is xy equal to 1, 1, 2, 2, 3, 3, 4, 4. 1, 1, 2, 2, 3, 3, 4, 4. These 4 elements. Now, x less than 2, y less than or equal to 6. Now, if you look at the first coordinates 1, 2, 3, 4 for x, only 1 satisfies x less than 2. So it will be 1 in the first coordinate. And if it's 1 in the first coordinate, y less than equal to 6. So y can be any value, 1, 2, 3 or 4. Doesn't matter. So it can be 1, 1 1, 2, 1, 3, 1, 4. But 1, 2, 1, 3 and 1, 4 do not exist in the sample space. So the actual space will be just 1, 1. The actual event space, this will be just 1, 1. Because 1, 1 is the only pair out of these 4 which satisfy this condition. So event space is this. Now what is probability of event? It is the cardinality of the event space E. So event space is E and sample space is S. So the cardinality of event space E by the cardinality of sample space S. The cardinality of event space is 1, the cardinality of sample space is 4, so it's 1 over 4. Let's see the answer. And the answer is 1 over 4 it should be. I don't know why it's given 1 over 10. Anyways, you can just check, and if you find the answer to be 1 over 10, then it's good. And if you find the answer to be 1 over 4 like me, please raise a dispute in the forum and we will solve it again. Okay? Thank you. Have a nice day. See you on problem solving session week 8 next Tuesday, same time. Thank you.